Alright, so this is my checkers game built using the Java language and JavaFX GUI. This is just a quick shot of the end result, and then we'll go talk about the code real quick, and then we'll come back and I'll demo the gameplay. Alright, so here's the code. So I built it first with using models. This way it's a bit modular, so I could build it to work in the console as a minimum viable product first, and then apply the GUI on top of that, which basically just talks to the models and makes checks. So I spent a lot of time going through the logic on this, because I realized in the beginning, after not too long, that playing checkers as a human being and how we perceive the game and the pieces is obviously very different from how the game sees it. So there aren't physical pieces or anything, so there has to be a way for the computer to keep track of where the pieces are and where the pieces aren't. And so going through the logic, I was able to figure out that what that means is that the board needs to create a 8x8 grid, of course, and then where there are pieces, it's going to put red, and where there are pieces that are black, it will put black, and where there are no pieces will be null in those squares. So after doing that, then we would need to be able to place the piece. So we need to get the row and column to be able to put it where it needs to go. We initialize the pieces by using a for loop to create the rows 0 through 2 and the columns 0 through 8. In checkers, all the pieces are on dark squares, so we can use modulo 2 equals 1 here to make sure they're on the dark squares, and we place the red pieces in rows 0, 1, and 2, columns 0 through 7, and then, because it's the index, and then for the black pieces it's rows 5, 6, and 7, columns 0 through 7, and again use the modulo 2 to make sure that they're on dark squares. I created this method so I could do some testing early on and make sure the dots are for where there's an empty square or null, and then of course these letters to show where there are pieces. We need to be able to get the piece at a specific location, so that's what we do here with this method. We also need to make sure that the spaces that we're placing a piece, or where a piece is, or where it's going to move to, is actually in fact on the board, and enforce the bounds. And then for gameplay, we have to be able to check, so in checkers, if there's ever a capture move, or a jump move, or kill move, whatever you want to call it, where one color jumps over another opponent's piece and takes their piece, if there's any capture move available, it's required, it's called forced capture, you're required to make that move. You can't move other pieces instead. So to check that, and also of course as part of the logic for the game and checking the winner, we need to be able to check if there's any capture available on the board, so that's what we do here. Again, we loop through the grid, we check which spaces are null and what colors the pieces are, and if there is a capture option anywhere on the board, and then here we use the logic method to check if there's a capture at all, because we need both, right? So we need to check if there's a capture in the immediate move and or anywhere on the board. We get the piece that we're planning to move, we make sure it is in fact a piece, we check the color, we check if it's a king or not, because that will change the ability of its direction. So let me go back to the board real quick. So again, I had to spend some time thinking through the logic on this. Red is going to, when it moves, the red pieces will increase their rows to move down, and the columns will change. So if this is 0, 0, so this is row 0, 1, 2, 3, 4, 5, 6, 7. Those are the rows, and these are the columns 0, 1, 2, 3, 4, 5, 6, 7. So red will move down by increasing the rows, and then of course moving to the right on the board is an increase in columns, and moving to the left is a decrease in the columns. And again, I had to think through that, because if you're the player, black, moving to the right, you would see it as increasing columns, and if red was moving to the right, you would see it as a decrease in the columns. But so you could use the logic that way, but I was using it, I did it from the perspective of the board, so I had to spend time thinking on that. So yeah, we enforce the move direction here. Red pieces, they can go down one row diagonally, so rows will increase and the columns will increase or decrease by 1. If a piece is jumping in or killing or capturing another piece that's in the middle, then of course the red piece would actually move 2 columns and rows. And so that's the logic here, and we are checking to see if it is a king, because a king can of course move in any direction diagonally. Don't want to spend too much time getting caught on this, but that's what we have here. So is there adjacent pieces? What about the landing space? We're checking those things and implementing that logic. Can we to move a piece, we're going to get its start row, start column, and then it's going to have an end row and end column. We check if it's on the board where we plan to move it. Obviously, if it's not within the bounds, then we return null and don't continue. Again, same thing, we check the piece to move. Can it move? We're checking color, the distance in terms of rows and columns. I'm going a little fast just to keep this video not too long. Alright, so... And then of course, if we jump a piece, so if a red piece were here and black's here, when black jumps the red piece here in the middle, so actually let's just do that. Oh, whoops, sorry, black has to move first. Okay, so if this red piece moves here, and black moves here, red moves here, okay. So if this black piece jumps the red piece, then we have to set the black piece where it was originally to null, and the piece it jumped to null as well. Alright, so let's go back to the code. Okay, so that's what happens here. If jumped piece is not null, we get the color, and we move the piece to the end row, and then we set null for the jumped piece or captured piece, and of course the starting location of the piece we moved. So just moving along. Now, in order to determine a winner, we have to be able to count if the player no longer has any pieces, and also if they have any moves left. So we check if there's, we count the pieces, we check if there's any simple moves, and do they have any legal moves, period. So we're making sure we have the logic here to determine the winner. Alright, let's go to the piece real quick. So we create the piece here, we've got our getters and setters, our constructor, basically just, is it a king, the piece, is it not a king, what is its color, yeah, pretty much. And then let's go to the game here. The game has its own logic, of course, so we've got our current turn, multi-jump or multi-capture, is there a winner, and the board. We create a new board, we initialize the pieces, black usually starts. In the beginning there's not a winner, so we run all our checks. So this is all the actual game logic. Can we move a piece? Yes. Is there, unless there's another piece there, like our own piece, and if the square isn't, if the place isn't null. We're counting the pieces, we're checking if there's any legal moves, is there a winner. So that's all the game logic. And then our main, so like I said in the beginning, I built this as a minimal viable product, so it first worked in the console, and then I built the GUI, or implemented the GUI on top of it, because I wanted to make sure it worked first, but also that allows to keep the functionalities separate and keep it modular, so I can make changes or adjustments to it. So the play again option, we get our user input. Sorry. Is there a winner? Whose turn is it? Enter moves. So in the console version, you enter the integers, so the start row and start column, and then where you want to move the piece for the end row and column. It's a little bit harder to play because you have to count the columns and rows. I didn't implement numbers on them so you could see, but I did test it to make sure that it works, and it does function correctly. So you input 4 integers, the 2 for the starting row and starting column, and then 2 for the end row and end column. Do you want to play again? I implemented that. Alright, and then real quick, I'll just discuss the JavaFX GUI. I spent a lot of time Googling and checking and trying to figure out what's going on, why there are still these red errors. I actually did check to ensure that the reference libraries are imported and are correct in my settings and launch JSON. So I was not able to determine exactly why some of these errors are here. However, it does not appear to affect functionality. And I did not have enough time, like I said, to finish resolving that. But again, functionality is still working. I'll just go through this real quickly. The JavaFX, we've imported all the things we need for to create the GUI. So our game, our buttons and labels, our stage, and the grid buttons. Again, this is all like the visual stuff that we see. Border, scene, grid pane, the size of the squares, and of course their locations and ability to click on them. So yeah, handle square click. What else do I need here? We need to keep track of we need to talk to the game models and logic to get the current turn, and then express that, whose turn it is, and if there's a winner. So basically the GUI is simply working with the models to communicate and get the data and information it needs, and then make it interactive or interact with it. So let's go to the game real quick and let's just demo it. I think I kind of already did, but so yeah, we've got a new game, and we click on our colors to move, and if I try to click on another color, it won't let me because of force capture. Now this is a flaw that I needed to fix. I didn't realize until testing. In strict gameplay of checkers, when you first click on a piece, like when you go to move a piece, if you actually touch that piece, you are required to move that piece. However, I didn't have time to work this out. This is an edge case I was testing, and what happens in this game is when there is a force capture, you are required to make the force capture. However, you aren't required to click on the piece for your piece to move for the force capture. So if you instead click on a different piece, you actually can't click on anything else to continue the game, and it gets stuck. This also happens if a piece is stuck in a corner and can't move, and you click on it to move, and there's nowhere for it to move. It gets stuck, and you have to start over. So I need to still resolve that issue. So let's just go back here and let's not make that happen. And let's just continue the game like as normal. So there's a force capture here. Again, if I click on something else, the game will not continue on because it will require me to make this move. But if I select another piece, it won't let me select the piece I'm supposed to. So for the sake of the demo, I'll just show you, I'll just continue the logic and not create the edge case. So if we do that, it clears there. These pieces are required to capture either one of them. Go here, and whoops, oh shoot, see, there's an example. So I'll just show you real quickly. Let's just demo a keying example if I can. Okay. And that's Red's turn. Again, that's something I needed to fix, is if it's not your turn and you click on, I need a little more explanation so it's a little more clear to people what's what, because I can see that the logic would be challenging. So, alright, here we go. So now it becomes a black king, and of course it can't go anywhere there, but if this piece moves, then we can do a double jump or capture. And you see it's still highlighted, and then this is required to capture. Oh. Alright, so... Oh, because it's red. Whoops. Okay. Sorry, red can't go backwards until it becomes king. Black goes here. Anyway, now you can see, so actually let's just demonstrate that the king has the ability to go back. See? So he can go any direction. Anyway, that is the game play demonstration. I hope you enjoy this. Thank you very much.